Hello, we are meeting again in the series of lectures under the topic of Statistics and Management Studies. Statistics is an applied branch of mathematics. It is used for collecting the past behavior of data, present accomplishments of data. Data means numerical data. So statistics is numerical data which is used for predicting the future course of events. The significance of statistics in management studies is that it is used for policy formulation, decision making, or predicting the future course of events. Economics, commerce, and management studies are requiring policy formulation or predicting the future course of events. Hence, we use statistics extensively in management studies. It has mainly two branches. One is quantitative techniques, other is operations research. Both the topics are used for formulating policies and for predicting future course of events. The quantitative techniques consist of correlation, regression, inferential statistics, sampling, etc. Where operations research consists of linear programming, network analysis, queuing theory, etc. Both these branches are related to numerical data. It has three phases. First one is collection of numerical data about the past behavior, the present accomplishments. These sets of numerical data are combined together and used for making predictions or for policy formulation. Then we are coming to discuss OR, operations research. Operations research is a problem of decision making. What about the decision making in management studies? There are only two possible decisions. One, maximization of profit. Other one is minimization of cost. Linear programming, network analysis, queuing theory, game theory, everything has the primary objective of decision making in terms of money. It is used for either profit maximization or minimization of cost. Then what are the objectives of decision making with respect to these two characteristics, profit maximization and minimization of cost? Profit maximization is the objective of an entrepreneur. It has two components. One is endogenous variables and the other is exogenous variables. Exogenous variables are a lot, whereas endogenous variables is negligibly small, 3, 4, etc. What is endogenous variables? The variables having influence. The entrepreneur have influence on these endogenous variables. For example, in the case of a profit maximization, majority factors are out of the control of the entrepreneur. They are called exogenous variable. Endogenous variables means the variables under control. They are the cost of the profit gain from a product or revenue from a product. What about the exogenous variables? The taste preference, demand, income, climatic conditions. Such a lot of factors are operating from outside. So exogenous variables are operating from outside, and on these variables, the entrepreneur has no effect. Therefore, the entrepreneur has to maximize profit by using a countable number of endogenous variables. So it is difficult to formulate policies. What he do? He take the other component. Instead of maximizing profit, his objective is to minimization of cost. That is comparatively possible for the entrepreneur. Minimization of cost related to several factors. That is minimization of advertisement cost, minimization of stationery cost, minimization of cost for requirement of the office maintenance. That can be achieved by the entrepreneur. So that is a problem of maximization of profit. Instead of maximizing the profit, entrepreneur is going for minimization of cost. Same is the cost of our teachers and students. What is our objective? Maximization of profits. Marks. How will you maximize? Answering the question paper correctly, then we get maximum or full score. But only 20% of the contribution is in our hand. The question paper should be easy, the evaluation should be correct, the tabulation should be proper, etc., etc. The students or teachers has no control. But what we do? The other part, minimization. Instead of maximization of profit, we minimize the time for other activities, entertainment time, the time spent for other activities. That we minimize, then we try to maximize the score. That is the primary objective of operations research. Maximization with respect to other. So we are going to discuss linear programming problem from this point of view. We have only two characteristics. One is probabilistic, other is deterministic. As we know, network analysis, CPM is deterministic, but is probabilistic. Probabilistic is the major component of a decision-making problem. So here also, we are going to apply the theory of probability or probabilistic. Then the primary objective of linear programming is optimization. Instead of maximization, we are going for minimization of cost. Therefore, we have two types of problems. The given problem, that is defined as the primary problem. It is known as primal problem. From this primal problem, we derive another problem. A problem associated with the given problem. Every problem is there with respect to a given problem. It is called dual problem. So here we are discussing duality in linear programming problem. This duality means a problem associated with a primary problem, primal problem. Instead of maximization of profit, our objective is to minimization of cost, which finally results in maximization of profit. So we are going to discuss duality in this class. A problem is exhibited on the board. There is a problem of maximization. A problem is given. It is called the primary problem or primal problem. Our objective is to maximize a problem. It has three variables, 1, 2, 3. That's a mathematical problem. In real situation, maximization depends on several factors operating from outside, mathematical or non-mathematical. In the case of price, revenue, the price of a commodity, the revenue of a commodity, the profit of a commodity, etc. are known, but they are influenced by other factors such as the price of other commodities, the income of the consumer, the supply of the product, the taste, preference, climatic conditions, several factors. They are called exogenous, operating from outside. Hence, instead of maximizing the problem, we are going for, that is for convenience, that's only for convenience. The problem derived from a primal, it is called dual. That is, in linear programming, every problem can be seen through the other part. That is a problem associated with the given problem. Associated, it is called duality or dual problem. We use primal or dual according to our convenience. The only word is convenience, no other thing. It is for convenience. So we are going to write a dual from the given primal problem. So primal problem has three variables, x1, x2, x3, and three constraints, and the cost coefficients are 3, 1, 2. The cost coefficients 3, 1, 2 cost coefficients, and they are the availability 5, 10, 15. These two components play a major role in dual problem. Let us see the pattern of formulating. Everything is changed. The first one, maximize. Instead of maximization, the problem is changed into a problem of minimization. That is the first step in duality. If the problem given in primary level is of maximization, duality is minimization. The minimization of Z dash, we are using Z dash, Z dash. How many constraints? 1, 2, 3. So we introduce 3 variables as 5y1 plus 10y2 plus 15y3. We use the availability coefficients. 5, 10, 15 are prescribed known constant. Our objective is to minimize. Is that minimization or minimize? Z dash is equal to 5y1 plus 10y2, 15y3. Subject the constraints. Here we are reading this root 1 subject to 1 by 1 plus 2y2 plus there is no y1 in the third constraint 0y3. We are not using that. The constraint less than or equal to is changed into more than or equal to 3. The second one y1 plus y3, y1 plus y3 is greater than or equal to 1. y1 plus y2 plus 3y3 greater than or equal to 2. 3, 1, 2 are the cost coefficients. That is, in primal problem, the cost coefficients are transformed into the availability coefficients. The availability are transformed into cost coefficients. For more convenience of this writing these constraints, we can formulate a coefficient matrix as x1, 1, x2, 1, x1, 3, 1, 1, 1. Here, 2, no x2 in second constraint, 0, 1, 0, no x1, 1, 3. Then we are reading in this way, 1 by 1 plus 2 by 2, 1 by 1 plus 1 by 3, 1 by 1, 1 by 2, 3 by 3, and as in the previous case, y1 by 2, y3 are greater than or equal to 0. That is a dual problem. What are the steps? That we'll discuss later. Transformation of problem, step by step, will illustrate. So this is the dual problem. Then one more thing. For the time being, ignore this problem. We are ignoring this one. We are going to write the dual of the dual. This is the dual problem. The dual problem. Suppose this is the primal problem. Now we are going to formulate dual problem from the formulated dual of the dual. So what are the conditions? So the problem is a minimization problem. Here our objective function is of maximization. In a problem, the components are decision variables, objective function, linear constraints, and non-negativity conditions. From the dual problem, we are identifying the variables, objective function, and coefficients. The variables are 3 constraints. We use 3 variables, Z1, Z2, Z3. And the cost coefficients are 5, 10, 15. In the dual problem, the availability coefficients are 3, 1, 2 in the problem. Then we are going to write down the dual of the dual. The first one is maximize. Z2 dash is equal to, we are using this is changed into, these coefficients are changed into cost factors. Cost, that is the duality property, that is 3Z1 plus Z2 plus 2Z3. And the coefficient matrix of the constraint elements 1 by 1, 2 by 2, 0 by 3, 1 by 1, 1 by 2, 1 by 3, 1 by 1, 1 by 2, 3 by 3. Using this, we formulate the constraints such that Z1 plus Z2 plus Z3, Z1, Z2, Z3 less than or equal to, less than or is equal to, this coefficient cost is changed. The cost is changed into availability. That is the property of this change in availability. That is, which is less than or equal to 5. Then 2Z1 plus Z3 less than or equal to 10. Then using this 0Z1, that is Z2 plus 3Z3 less than or equal to 15. Z1, Z2, Z3 is greater than or equal to 0. Then now we refer to our given problem. This is the formalities for the primal duality. Then what about the given problem? A problem is given to us as maximize. Our given problem is maximize. Z is equal to 3x1 plus x2 plus 2x3 such that x1 plus x2 plus x3 less than or equal to 5, 2x1 plus x3 less than or equal to 10, then x2 plus 3x3 less than or equal to 15, x1, x2, x3 is greater than or equal to 0. The problem is same. 3z1, z2, 2z3, z1 plus z2 plus z3. This is the given problem. That's a very important result. What is this? This is the dual of the dual. Dual of the dual. The dual of the dual is primal. That is a very important result in duality. That is dual problem. From a primal problem, we derive a problem that is primal. Then we formulate dual. Then we again formulate a dual. That is dual of the dual. Dual of dual. That is the primal itself. Dual of the dual is primal. Dual of dual is the given problem, that is primal. We prove that dual of the dual is primal. The given problem is primal. The problem formulated from is called dual, that is associated problem. If you formulate another problem from the dual, it is the primal. That makes a complete circle. Dual of the dual is primal. We discussed the problem. Now we are discussing the conditions, theoretical conditions. So starting with the given problem, a primal problem in the standard form. Objective function. In the standard form, the objective function is of maximization. Constraints are of the less than or equal to type. And as usual, the non-negativity conditions. It is a real life problem. All variables always are positive or non-negative. This is the conditions for a standard linear programming problem, which is identified as primal. From this primal, we formulate a dual. So what are the changes? The objective function is transformed into minimization. Here it is maximization in the primal. In the dual, it is minimization. The constraints, here it is less than or equal to. It is changed into greater than or equal to. And no change in the non-negativity conditions. If the constraints are less than or equal to in primal, it is more than or equal to in dual. Then from this dual, we are going for the next problem, that is known as dual of the dual. We just proved that is a primal. Then again going to primal, objective function is of maximization. From the starting point, maximization. Constraints less than or equal to type. Here it is greater than or equal to. It is changed into less than or equal to, and no change in non-negativity conditions. This is the primary necessity for primal, dual, and again the dual of the dual, that is primal. Then some idea about the number of variables, the number of constraints, etc. A linear programming problem has 4 stages. Decision variables, objective function, what is to be achieved. Then how will you achieve? Using availability and requirement. Availability is restricted, requirement is unlimited. So we have to make a balance between availability and requirement. Requirements are unlimited. Here the subject statistics plays a major role between availability and requirement. So we are introducing that terminology also. Objective function. First one, we have to identify the objective function. Objective function is changed into, if it is given minimization, then the other one is maximization. If it is maximization, the other one is minimization. That is the first thing. Then about the number of variables. If we formulate a dual, we have to decide about the number of variables in the dual problem. That is, the number of variables is equal to the number of constraints. Number of constraints. In the primal problem, how many variables are there? Then the dual problem, that is the number of constraints. Number of variables is equal to number of constraints in the primal problem. And the cost coefficients. Cost coefficients. The cost coefficients and the availability coefficients are just changed, or they are availability coefficients changed into cost coefficients, and cost coefficients are changed to availability coefficients, and one more thing, the most important thing is how many variables, the number of constraints, how many constraints in the primal problem, number of constraints is equal to the number of variables. Just illustrate once again. Now we are reaching at the culmination point of this lecturing of duality. So here I am exhibiting the problems in primal and dual in a nutshell. What are they? If the primal has an objective function of maximization, the dual has of minimization. If the dual has a minimization, then its dual is maximization. Primal, dual, and again dual of the dual. Maximization, minimization. If it is minimization, that is maximization. Just reversal of roles. Then, about the number of variables. Linear programming problem, the first component is number of decision variables. In the number of decision variables in primal is equal to the number of constraints. That is again reversal. And the number of constraints, how many conditions, how many restrictions, how many available requirement conditions. That's the number of constraints. In the primal, the number of constraints is transformed into the number of variables in the dual. Variables, constraints, variable, just changing the rules. The cost coefficients, maximization, the cost that is transformed into availability coefficients. And the availability coefficients of the primal is the cost coefficients of the dual. And again, vice versa. Minimization, maximization. Number of constraints, number of variables. And there is one factor having no change. That is the non-negativity conditions. We assume always non-negative variables. So this is the theoretical background of formulating a primal problem, a dual problem from a primal, and again a dual. And we know that dual of the dual is primal. Maximization, minimization. Number of variables, number of constraints. Number of constraints, number of variables. Cost coefficients, availability coefficients. Availability coefficients, cost coefficients. Non-negativity conditions, non-negativity conditions. So what is the purpose of this? That is for convenience. So here the duality is used for convenience of the problem. It is used for solving a problem. That is, in one word, it is convenience. The only factor is convenience of the problem. There are two problems always. Profit maximization, instead of that cost minimization. Cost minimization, instead of that profit maximization. So duality is used for convenience. But for students, that is not for convenience. Suppose we have a problem of minimization. Our constraints are having greater than or equal to sign. Then we use surplus variables. Surplus variables is used and we cannot solve using the coefficient of surplus variables. In that case, we use a method known as big M or artificial variables. It is not easy for solving use. The number of steps, number of iterations will be more. The number of coefficients will be more. Therefore, for convenience, I am repeating that word again, for convenience, we formulate duality and we solve duality instead of primal problem. And from dual simplex method, dual solution of the problem, we find the solution of the primal problem. Then in the next class, I am going to discuss a method other than big M method for convenience. So for time being, concluding here, expecting the next class of duality, simplest method in duality. That is for convenience. Thank you.